Hello everyone and good evening to one and all present here. So I think it is already 6 p.m. so we can start with our webinar.
Very good evening to all who have given their immortal presence to the webinar on machine learning. Through this webinar, all the participants can be able to explore the machine learning from the basic. This session will be presented by Mr. Aravindan Balaji. A few keynote about the speaker. Mr. Aravindan Balaji is an engineering graduate with a specialization in information technology and a product development at Hazura. He was a full stack developer at Cognizant Technology Solution and a recipient of Digital Commerce Prodigy 2018 RGSPH CTS. Now currently he is pursuing his MS in Computer Science at University of Massachusetts Lowell. And I am very proud and overwhelmed to introduce the speaker, Mr. Aravindan Balaji, since he is the alumni of Panimalar Engineering College IT department. Now, without any interruption, the session will be handed over to Mr. Aravindan Balaji. Thank you.
Hello everyone and welcome to this webinar titled Introduction to Machine Learning and its Application. I am Aravindan Balaji and I am currently pursuing Masters in Computer Science at University of Massachusetts Lowell. Thank you everyone for being here and for having the interest to know machine learning. Let us start a journey of machine learning right now. So, first of all, I thank IT department of Panimalar for giving me this opportunity. I'm starting this webinar. The aim of this webinar is to introduce students to machine learning, to highlight some areas of applications, to familiarize students with the most common tools for machine learning, to walk through the different steps in a machine learning problem, to recommend some problems to solve, and to suggest a learning path to continue learning. This learning path will be in such a way that you slowly progress from the start and you become good in machine learning so that you will be very comfortable in doing projects in it. So first, before knowing how to do, we need to know what is machine learning. For that, let's go down our memory lane. So when you were young and you were first trying to ride a bicycle, you would have been a beginner and you would have struggled a lot on your first day of bicycle riding. And as you do it again and again daily on as a routine, you would have become better. The same strategy applies to machines as well. The machines are also dumb or doesn't have any skill at the start. But as it keeps doing the same thing again and again, or it gets experience, it becomes very good in that task. So how the machine gets this experience is what defined by different types of machine learning. So let us explore the types of machine learning now. The first type of machine learning is supervised learning, and it is one of the most popular type of machine learning because it is most implemented. And in supervised learning, the learning is guided. From the name itself, we can understand that it is supervised. So we have a teacher who says whether you're performing well or whether you need to improve or not. And there is a specific evaluation. And the learning is directed by examples. That is, the teacher gives you a set of examples, like previous examples, like this person has done like that and the result is this. So using that, the machine will learn that if we do these actions and the result will be like that. So this is also formally called as the training data in the machine learning world. And the machine will make use of this training data to learn how to do the task. And supervised learning is further subdivided into classification and regression. Classification is categorization. That is, you give set of data and features, and the machine will be able to categorize into one of the labels. It could be the number of labels could be 2 or more than 2. And for example, it could be classifying between a person has a heart disease or he does not have a risk of heart disease, or it might be classifying to different breeds of dogs. So it totally depends on the problem. The next type of machine learning is regression. In regression, you're taking in the training, and then you are predicting the future value, and it is not a category, it is mostly like a numerical value. For example, you give the machine the historical stock market data, and then the machine will learn those data, and then it will try to predict the future stock price of that company. That is one example of a regression problem. The next type of learning is unsupervised learning. From the name itself, you can understand that that we don't have any supervisor or teacher. You are left by alone, and it is like self-learning. So you're giving a data set to a machine, and the machine will discover new patterns from it. And you're not giving any example or any clue about what is present in that data set. You just present it, and the machine should be able to find some new patterns from it. The problem types in this type of learning include clustering. For example, you give a customer data set which has a customer buying patterns. For example, let us take a grocery shopping at the supermarket. Each person will be buying for a certain amount for every month, and the pattern will be almost identical every month. So some customers will be buying for a very huge amount. Their family must be very big, so they might be having a very big list. And then there will be middle section where they will be buying in the middle range, and there will be another section will be buying very less groceries. So based on that, if you give that data to the machine, it should be able to segment them according to their buying patterns. So that is one example of the clustering. It also applies to the company level also. That is called market segmentation. And this is all about unsupervised learning. Reinforcement learning is learning through policies. It's like you have a sequence of actions, and you see whether the sequence of action leads to a success or defeat. If the set of actions leads to success, you'll be rewarded, and if it leads to defeat, then you'll be punished. So this is mostly used in robotics. Like the robot will do a sequence of moves, and if it results in some desirable characteristics, then it will be rewarded, and it will be given extra points. And if it results in some deleterious actions, then it will be punished. So it is more like a gaming setup, and exactly this example is going to explain that. AlphaGo is a computer program that plays a game called Go. It is more like chess, a board game, in which a company called DeepMind developed this AlphaGo, and this AlphaGo computer program played against the champions in this game, like Lee Sedol, who has been champion for a long time. And surprisingly, the AlphaGo won 4 games out of 5 games they played with each other. So that powerful reinforcement learning is. So reinforcement learning is used in this gaming kind of setup where you give a sequence of instructions called policies. So that's about reinforcement learning. Application areas. So nowadays, machine learning, you don't need to talk about application areas because it is intruding in almost all the areas. Even people are afraid that it might take our jobs as well in future. But right now, it is dominating the healthcare industry, where it is supplementing the physician's advice because it analyzes the data and it gives results. So it will also be helpful for physician. And autonomous vehicles, I think everyone would have been amazed when Google released that they are working on these autonomous vehicles, and we were like confused how it is working. So the driver behind autonomous vehicles is nothing but machine learning. And then stock predictions, many of us are interested in stock market predictions, and we wanted to gain money out of it. So in those cases, machine learning problems like regression can give you a future stock market value and can help you make informed decisions. Natural language processing, this is our friend because we see this in Alexa, Google Home, and everything. we just sit at a place and we just give it commands, play this song, play that song. So it is more like a friend, and it is also making us lazy, but it has some interesting applications and future prospects uh, for this part of machine learning. And then weather prediction is an integral part of our life. Like we see the weather prediction before we start to a place or we plan any event. So machine learning also helps in weather predictions. So I have highlighted only five application areas, but there are more and more. And machine learning is going to stay with us in all the applications that we are using day to day. And that's about the application areas. Now let's see the tools. Before starting something, we need to know what all we need to be equipped with the tools that we need. So the tools are from the programming language perspective, Python is the best because it has a lot of machine learning libraries. You can use MATLAB as well. MATLAB is good, and Octave. Octave also helps you. But the best two is Python. Best two are Python and MATLAB. But I personally recommend using Python because of the availability of large number of packages that will help you in doing machine learning. And then Jupyter Notebook. Jupyter Notebook is it's a programming environment and is a web-based application. How this is suitable for data science project is that you can run a block of code. You can segment your code into different pieces, so it will help you to show the different steps in the machine learning project, like data processing. You can write a bit about it with comments with description. So if you are planning to do a lot of machine learning and data science, make this as your friend and start downloading it today. It's high time that you start downloading it. And there are more such features. I think you can, if you use it, you will come to know the other features. And scikit-learn is the man of the show for machine learning, because scikit-learn does all the heavy lifting when it comes to Python, and it is there in almost every section of machine learning. What you want classification, you want clustering, you want metrics. It helps you with everything. So it's like you name it, we have it. So that kind of package is scikit-learn. So those who are going to do machine learning, please start learning scikit-learn from by its documentation. NumPy. I think everyone knows the importance of NumPy for machine learning, because NumPy allows you to create n-dimensional arrays. You can load the data set into n-dimensional arrays and do numerical computation very fast in a fraction of a second. And it has many other mathematical functions inbuilt. So you don't need to move your hand. You just need to use this. Use the functions that they provide, and you can easily do most of the functions that you need for machine learning. And then pandas is another library that helps you with data analysis and manipulation. Almost more than NumPy, will be using pandas only, honestly, because when you load a data set, you will be loading it in a data frame, so that dropping it or making any alteration to the data will be very easy. So pandas is also a very good library, and definitely start learning pandas as well. And matplotlib and Seaborn. When it comes to data visualization, these two are the kings. So matplotlib is the base library and Seaborn is built on top of it, but both of them support all kinds of charts and all kinds of plots that you want to draw with your data. But Seaborn gives a more visually appealing visualization because it's more advanced. So start learning these packages as well to do data visualization. So that's about the packages. So let us. So I'm going to explain. I'll be explaining with a project, so you will know the importance of these packages as we go through this webinar. Classification. So classification is the most common problem. So that's why I am stressing on it, and I am showing a full application and a full. I'm going to walk through each step in a classification problem so that from today you can get started with the classification problem, machine learning problem. And classification, as I told before, is nothing but categorizing an object based on the training that you receive from the training data set. For example, so there are two types of classification. One is binary classification, and another one is multi-class classification. So in binary classification, it's going to be just two labels. You either classify it as a cat or a dog, for an example. And in multi-class classification, you are learning the data, you are learning the training data, and then you are classifying the different breeds of dogs. It might be 5 breeds, it might be 10 breeds. It's just nothing but more than two labels. So that's how it differs based on the number of labels. And then algorithms, there are like these are the main algorithms used for classification problems. The first one is linear regression, and then logistic regression, naive Bayes, support vector machines, decision trees, and random forest. All these algorithms do very well in classification, and we can't say which one is best out of it. It all depends. In machine learning, you can't decide the best algorithm. You just need to try out with all these algorithms before coming to a conclusion. So I'm not going to the mathematical side of these things. So if I go to the mathematical side of these things, I might need a separate webinar for each of these algorithms. So I'm just going to say that these are the algorithms you will mostly be dealing with in a classification problem. Data set. So the importance of data set is so high that you will realize now. So there are, I could say that 50% of your job is done if you get a good data set. So I can't stress this more, the importance of a good data set. Because in a supervised learning or classification setup, the data set decides the quality of training. So you need to have a very good data set to start with. You never compromise on this aspect of not getting a good data set. So whenever you're starting a problem, you make sure that you have a good data set. And data acquisition is a difficult task. Like you might think if you want to acquire your own data set, you might think that it is an easy task, but it is not so, because getting data from your resources, following up with them, and then preparing it in a right way so that machines can learn it faster is not an easy task. It does not happen in a couple of days or more. You need to start. If you guys are planning to prepare your own data set, please start 1 or 2 months in advance, because it will take more time than you expected because of the issues that you might face in between. So I'm a personal victim of this, so I'm advising this and giving this caution to you guys who are going to start in future. And then, so if you don't have the time and resources to collect the data, and prepare your own data set, the next option is to use the already prepared data set available on the internet. So the best source for that is UCI Machine Learning Repository. So UCI stands for University of California Irvine Machine Learning Repository. These guys are very generous that they are collecting data and pre-processing it and then loading it on their website for use for research purposes. And let me show you that repository, because this is going to be a place of start for everyone who are going to start a machine learning project. So you can go to the UCI Machine Learning Repository by just a Google search. It'll be the first link after your search. So I'm going to the UCI Machine Learning Repository. So as you can see that this is the homepage of UCI Machine Learning Repository, and these are the most popular data set. That is the data sets that have been used more frequently, and you can also search it as well. You can view all the data sets if you want. If you don't know, if you're first exploring the data sets that are available before starting a problem, you can just click on view all data set and you can explore what kind of data set that you want. You also have the types of data sets like multivariate, means it has more than 2 3 labels and it is used for classification task. You can check this task and you can go for this data set as well. And this is one of the sources, and most of the US universities do this. So you can get a data set out of .edu websites, because they do it for research purposes, and it will be pre-processed and well prepared. You can directly go ahead and use it. And the next source is Kaggle. So everyone who are aspiring to become a data scientist might know Kaggle. So let us show Kaggle to you. And Kaggle also has some data sets, but the Kaggle is open to everyone. Even I can upload a data set today. So I can't guarantee the quality of data sets over here. Some of them will be high quality because organizations might be adding it. For example, COVID-19 open research dataset this is by NIH, National Institute of Health, so it is high quality, and a lot of people are trying to solve this challenge. So you don't need to doubt about this, but there are individual contributors as well. So I cannot guarantee the quality of that, but you can search and get the good datasets from Kaggle as well. And the next one I want to tell is metadata. So when you get, I'll show you the example of one data set, which is the heart disease data set. So this heart disease data set has been contributed by 4 researchers. So whenever you use a data set and you're doing a project that leads to publication, please see the citation request, because these researchers might ask you to cite their names in your papers. So if you're publishing something, please add that in your publication. Add their names in the publication. So metadata is information about your data. So this is the metadata about this data set. I just wanted to show its importance by downloading the data set. First, I'm going to download the data set, and I'm going to show why metadata is important in all cases. So I'm going to download the process Cleveland data. There are data from multiple places. I'm going to use this Cleveland one, and then it's downloaded. So I'm going to show how the data set looks like right now. So it looks like this. You don't have a field name. You don't know what these values mean. You just know that there are 14 columns in this and they are comma separated with this CSV format. So you just know that there are 303 values in here, that you don't understand what it means. So for that purpose only, you need to know the metadata of it. So the metadata of this data set has been given here. So the 14 fields, what those 14 fields mean here is given. So you can go through this. So metadata describe your data, what each field means and what importance does it have in the data set. So that's why you need to know the metadata. And then and in terms of data set, I need to talk about the volume and quality as well. So if you're going to train a machine learning model, the data set should be of good volume. That is, there should be a lot of many records, not few records, because the more the records, more the machine will be able to learn from the data set. And even the quality of the data set also matters a lot, because many data sets have some inconsistencies in them. In those cases, the machine will not be able to learn well from them. Think of the example that your teacher is giving you some examples, and some of the example book and some of the pages are torn from it. So that is the example that you need to know. You will have some incomplete knowledge in that case. So that's why I'm highlighting some of the common issues that you can find in data sets. It's nothing but you can find issues like null values. Some of the fields might not have values in few records. So that is a problem, because machine will get confused. The quality of the overall training will be reduced because of null values. So when you encounter null values, there are 2 remedies. Either you have to remove it. If the number of null value records are small, then you can directly remove it. Or otherwise, you can impute the mean values. You can take the mean values of that field and then enter those mean values in those records. So that is another solution. So whether you remove it or add the mean value totally depends on number of null values in the data set. And the next one is class imbalance. Class imbalance is nothing but as I told, in classification problem, you have labels as well. So in labels, if the number of labels of one category is way more than other, like the number of cats records are 50, and then their dogs records are 150. There's a significant difference between the two types of records. So in that case, the machine will know more about dogs than cats. So it will whenever you give any data, it might give some wrong prediction as well. Most probably it will give dog, even though it is cat, because it has learned more of dog than cat. So there should be an equal amount of records of all classes. That's what that's what I mean by here, class imbalance. So in that case, you need to try to get to a equal number of records if there is a class imbalance. So I will show you the data set, the final label. So let us prepare our data set. It is given in the form of .data. So most probably we'll be using CSV format. That is the most friendly format for data. That is numerical data, because in Pandas you have a function read CSV. You can directly read it. So I'm just going to change it, and changing that is also pretty easy. I'm going to rename it so that it will be easy for me. I'm going to name it data.csv. It will directly get converted to a CSV format. It might give an error message or a caution message like this, but you can rename it. You can go ahead and rename it. And so it has been converted into a CSV or Excel comma separated format. So now you can go ahead. Now we can go ahead and you can add the now you can go ahead and you can add the fields from using the metadata. You can add the names. So I'm not going to show that because I already have done that. And the last field in all your data sets in a classification data set will be your label. In this case, there are 0, 1, 2, 3. So I think there are like 5 types of 5 labels. That's what I meant. This is a multi-class data set, multivariate data set. You have like types from 0 to 4. And this is always the final column will be a label column. That's what I wanted to show here. So you can prepare the data set by adding the field names there, so that it will be easy for you to load in the data set. I'll be showing I'll also show you the loading part. So now that we have talked enough about the data set, let me show you how to load with an example, with the use of an example. So now I'm going to show all the steps of the project with use of an example. This is the project that I did for my course here. So it's called heart disease prediction. So I've used the heart disease data set from the UCI machine learning repository. And heart disease is one of the major causes of death in the United States. So that's why I took this problem here. And so first, whenever you start a project, you need to import a lot of things. The default one as Pandas, you don't need to think about it. You can just do it closing your eyes. So, without thinking. And you can import Pandas as always use a short form as well, so it will be easy to utilize later, because you'll be utilizing it frequently. And you can import NumPy as well. You can import Seaborn. You can have imported Matplotlib. So initially you'll be importing at this point of time you'll be importing this only. All these ITER tools is something that I imported later, but for now you can import Pandas, NumPy, Seaborn, Matplotlib, because definitely you're going to use it right now. So loading the data set is very easy. As you can see, we are using Pandas, so we declared Pandas as PD. So we will be using that PD, and read CSV is an inbuilt method in Pandas which you can use to load a data set. And you are using read CSV, and since we renamed it data.csv, I'm giving the file name. I think at this point of time I had the data set in this same folder, so I have give data.csv. If it is in a different folder, if it is in a different folder, if it is in a different folder, then you need to give the relative path to it. Once you do this, it will go to a data frame. In Pandas, everything is a data frame. It's just like how you store the records in Pandas. So in just one line, you have already loaded the data set into this program. Hello. Panita, ma'am. Panita. Thank you. So, so once you load the data set, you can use the head method to just see whether it has been loaded properly. As you can see, I have added the labels as well to that. Labels are added to the data set, and I have named the label data set as diagnosis. So once you have done with that, you can see the info as well. You just need to use the function info from pandas, and you'll get the info how many records are there and what type of data is stored in it. Everything you can get to it. So that's about. So we have loaded the data set, and we have seen that it has been successfully loaded. We have seen the info as well. So let us go to the next step of any machine learning project. So the next step is data pre-processing. As I told, there will definitely be some inconsistency in any data set, just like null values or class imbalance, and we definitely need to pre-process it in data set like machine learning repository. It will already be pre-processed, but still we will have some work to do. So in that case, as I told, the most common problems in data set will be null values and class imbalance. And let me show you from a programming perspective how to deal with null values from the project. So let us go to the data pre-processing section of this project. And so we have the data in form of a data frame inside this data variable, and we need to see whether there are null values in this data set. To do that, you need to use the isNull function of pandas that is also already available. So and then you have to click the sum, because if you give isNull, it will list for every record. So if you sum it, it will just average all the fields, and it will give there are like four null value records for that has null value in this field, and there are 2 records that have null values in this field. So there are totally 6 records in this data set that has null values. So it confirms my previous statement. Even data set from UCL machine learning repository will have some inconsistency like null values. So what I'm going to do next is just since the number of null values is just 6, I'm just going to remove it. For that, I'm going to first remove the null values from of the records which has null values in CA field, and so the first I'm going to access the CA field from data set, and then I'm using the function isNA, which means whether it gives a Boolean values of all the records that has null values. So and then data location is going to get a location of these fields. So first this will return the isNA function of pandas will return the records which has null values, and then location will give the location of those values, and you will be able to access those values in access those records in CA variable. Once you get all those records, you can just drop it. Drop it is nothing but deleting it from the. You might have seen in SQL or some SQL where you drop a table. So same thing applies here. So you need to give the data set, and you're going to dropping those specific, and then you're accessing those fields by index, and then you have a pre-processed data set. So you have removed 4 records which has null values in CA field, and then you're doing the same for TAL field as well. So I'm not going to repeat it. So once you have done, you can again see the info. You'll now see that previously it was 303 fields, 303 records. Now it has become 297 records because we have removed totally six records from that because they had null values in it. And so we have dealt with null values now. Now let us see whether our data set has class imbalance. So for a class imbalance, you can use the method called value counts. So this is a process for I'm converting this into a binary classification problem. We saw that we had 5 labels 0 to 4, but I just wanted to see whether they have heart disease problem or not. So I am just converting it into a binary classification problem. and then I want to see whether these fields have this data set as class imbalance. To see that, I'm using the function value counts. Value counts gives the number of records for pertaining to each label. For 0, there are 160 records, which means negative case. And then for positive cases, there are 137 records. So this is more or it can't be perfectly equal, but it is more or less equal. If it had been like 160 and 80, definitely we should act on the data set right now, or we should change the data set bit, because you have almost half the number of records as the negative cases. So that won't be helpful for learning. So you just need to change the data set, or you need to remove the other 80 fields as well. So this is how you deal with class imbalance and null values in a data set. And so I've mentioned that you can use isNA function and value counts to see for the class imbalance. So pre-processed data set gives better accuracy. Definitely, if you have inconsistency in the data set, machine learn the model will not learn it properly. There'll be issues in accuracy later on. So it is better to pre-process the data set before start working on it. The next one is data visualization. This is a very important step, because you understand the data yourself, and then you are giving an understanding of the data to others who are viewing the notebook. Just like me, I'm viewing the notebook again, and I will get the idea again. So for visualization, there are two packages which leads this domain, which is nothing but Matplotlib and Seaborn. And Matplotlib also supports line chart, bar chart, pie chart, scatter plot, histograms. And even Seaborn does the same histogram scatter plot, but Seaborn is a little bit visually appealing because it has been built on top of Matplotlib. But what you want to use, it entirely depends on you, and what kind of chart you want to use entirely depends on your application. So let us see the data visualization part of our application. So we have come to this data visualization part, and it's going to be, I've used Seaborn here. I showed at the start, I've imported Seaborn as SNS. So I'm going to use the short form only, SNS only, to use the functions of it. First, before drawing any chart or line chart, you need to set a context of it. Paper is nothing but a paper background. Just you can see a white background here. So I've used paper. There are some other backgrounds like notebook, which has some grid lines also. It entirely depends on what your application, what kind your preference. Font scale is nothing but the weight of the font. If you change it to 3 or 4, the font might be bigger. And RC is used to change the preset Seaborn values. So you can change the font size. There will be some preset values for the font size, the axis title size you want, but you definitely have to customize, right, based on your application or based on your preference actually. So you can change it using RC parameters like font.size, giving a value. You have to give it in a double quotes, all these parameters will be available in Seaborn's documentation. I will show you the documentation as well. And there are different types of plots. The main plot I've used is count plot, because I didn't have any other necessity to show here other than showing the counts. So to use that, you just need to use sns.countplot, and then you have to give the field that you want to project here. I'm just giving the diagnosis field. If you remember, this is our label field. So I'm going to project just the diagnosis field, and I'm going to give this chart a title to give an idea what viewers are seeing. So now I'm new to this, so I can get an understanding that I'm visualizing negative cases versus positive cases using a count plot. So we have successfully using this count plot method, you can plot the number of cases of each type. And the same applies to everything else. So I've just shown one example, and I've used only count plot, so I don't have example of any other charts here. But I can show you the documentation of Matplotlib and Seaborn, which will be very useful for you. You can go through it and you can use whatever you want based on your application. So this is the Matplotlib website, and you have a good documentation. A good documentation is very important because it will attract more developers to use it. So Matplotlib, when you come to Matplotlib, you can click on documentation, and then you can click on documentation to see step by step. If you want to learn in a formal way, you can see the documentation, or otherwise you can use the examples. Examples another way of learning. Like they give the output of it, and then they give the code as well. So you just need to copy this, and you can change the field values. Like based on your data set, you can change the field values here. So there are more such examples of in Matplotlib. As Seaborn is well documented as well. So let's go to Seaborn documentation. So here you need, I think you have an example gallery. So as you can see, it is more visually appealing than Matplotlib. It is like working on top of Matplotlib, and even this has the code. You can just copy it, and you can use it in your application. So if you want to learn more about Matplotlib and Seaborn, I've given the links to these YouTube videos. These videos deal specifically with these packages, and I will retain this video in my channel. When you're starting your project, you can come here. You can watch this video when you're doing your data visualization part, and you can start doing visualization as well. Data splitting is testing data. So when you deal with healthcare data or anything where you can't get the testing data, like you need instruments and need patients to get the testing data. That is not possible. Training data you can get from these sources, but testing data you can't readily get. So in that cases, what we can do is we have to split the data set that we have into training and testing part. You can split in the ratios like 80-20 and 70-30. These are the most common ratios used. And so it entirely depends on the size of the data set. If the size of the data set is small, then you can go with 80-20 because you need more records for the training. You can just use more of it for testing. And if you're using a large data set, then 70-30 is fine. And standard scalar is a method that is used to convert all your values in a specific range, so that the machine learning the model can learn it quicker than having it in a different range. So standard scalar is one such method. So I'll explain this in the application. So let's go to the data splitting part. So in data splitting part, I'm just splitting it into X and Y. X is nothing but the feature vectors, everything other than the label. And the last one, just the label, is there in another variable called Y. And then I'm going to use a function called train test split, which is available in scikit-learn. So it's available under scikit-learn's model selection module, and you can get it like from scikit-learn, sklearn model selection import train test split. From the name itself, it's understood that it is splitting training and testing. And once you have your feature vector and your label vector, you just need to use this train test split function, and you can give this training vector and the testing vector as the input. And then you're giving the test size 0.2. You always give 0 to 1 in a range 0 to 1. 0.2 means 20% of the data set goes to test. So that way you can mention this parameter over here. And then all the value, these are the default naming conventions for your data science projects. So when you're splitting it, you can just split into X train, X test, Y train, and Y test, and you have to supply these variables so that it will be able to give those values to that. Next, let's see the standard scalar and C's use. So standard scalar, as I said, it will convert all the values in a specific range. So for that, you need to first import the standard scalar from the scikit-learn pre-processing. Once you got the standard scalar, you can convert the testing and training to that specific range. So first, I'm going to convert this the feature vector training columns to specific range. For that, I'm going to use sc. You can use a function called fit transform, and then you can give the field. And then when you give the variable, you will get all the values in a specific range instead of its normal one. And then even for testing, I'm going to use the same thing. You can use a transform, and you can just directly load that into a variable. So right now we are almost done with the data set. We have we have loaded the data set, we have pre-processed it, we have visualized it, we have splitted it as well. Just a minute. So we have splitted it as well. So we are almost done with the data part. We are ready for the exciting part, with this training and testing. So when it comes to training and testing, scikit-learn comes to the rescue. It does most of the part for you. It makes your task so simple that you can just complete your training in just 3 lines of code. For example, to train a support vector machine, just a minute. To import and train a support vector machine, you need to use from sklearn.svm. Import svc stands for support vector classifier, because we are dealing with classifier problem. And then you need to create an instance of that classifier inside this variable. Once you have that instance of this variable, you just need to use the method fit. So once you have the fit, you need to give the training and the training column vectors and the label to fit that model with that training data. Once you are done with training, you're almost done. With 1 line of code, you have trained your training data to that model, and SVMC now has been trained on the training data. So you just need to try out a new data, which is nothing but the testing data. So in that case, the method that you have to go for is predict. So you have to give the instance dot predict, and then you have to supply the testing data to it, and it will give you the resultant values, like whether it will give all the labels it belongs to. So let me show this in the project perspective. So I showed you support vector classifier. Let us see other classifier as well, like random forest. Random forest is also a very good classifier. It gives good results. So for that, every classifier will be available from scikit-learn. So it might be under different categories. For example, random forest will be available under ensemble, because by natural it is an ensemble classifier, because it has a number of it is a combination of the decision trees. So it's available under ensemble, and you can import it. And once you import it, you can just fit it. As I told you before, you just need to fit the column X, column vector, and the Y label, and then you can. So with this line of code, you have done with the training, and then you're going to predict it. So I'm going to use the same instance, and then I'm going to predict on the test data set. Once I've completed prediction, I can store it in a variable. So I have printed that variable, 20 values of that variable here. So it has given 0, 1, which are nothing but the labels, the negative cases and the positive cases. So all the predicted values will be available under RFC predict. So same way I've imported the other classifiers as well. I've done with major classifiers like random forest. I've imported support vector machine, and I've imported decision tree, which is called decision tree classifier. I've run the procedure is the same, just the name that you'll import will be different. And even Gaussian naive Bayes, there are different types of naive Bayesian, but Gaussian naive Bayes is best for this data set, so I use that. Then logistic regression is also I've imported, and I've used it as well. So these are the major machine learning models or classification algorithms that you can use. So the training and testing of a model is that simple. So that makes your job easy, right? You can just complete in just 4 lines of code. So once you're done, you need to evaluate your model, whether it is doing good or not. You are playing the role of a teacher. You are now giving marks to the model right now, how you're performing, how many answers you have given right. So for that, you need to know accuracy is exactly the same. Just like we get marks, even model will get a mark. Accuracy is nothing but percentage of correctly classified instances. So out of all the instances, for example, test data might have 40 values. You would have given 40 records, and it would have predicted 30 out of 40 correctly. Then the value will be 30 by 40 into 100. That is the accuracy of your model. So F1 score is another important metric, which is harmonic mean of precision and recall. It will get a it will give you a uh, good idea of how well the model is doing. For example, it focuses on how many wrong, incorrect precision is mostly dependent on how precise it is, how less the number of wrong corrections are there, and recall is also based on the same thing. So F1 score is also a very good metric to show to evaluate a model. And then AUC ROC is nothing but area under curve and receiver operating characteristics. So in some cases, in data set which has class imbalance, accuracy is not a good score, because most of the time it is going to give you the result of the records which has more number of records in the training data. So in that case, you need to go for AUC ROC. AUC ROC is will explain whether the model, how good your model is in distinguishing between different classes. So AAC ROC is a very good metric, specifically for classification problems. Confusion matrix. Confusion. You're going to see a lot of confusion matrix in classification problems. This is a sure shot because everyone will be using this confusion matrix. So it is a matrix that shows the number of true positive, true negative, false positive, false negative. True positive means the actual value is positive and your prediction is positive as well, so it is correct. And true negative is as actual value is also negative and your predicted value is also negative. And false positive is like the actual value is negative, but your prediction is false. Your prediction is positive, so that is wrong. False positive or incorrect thing. And false negative is your actual value is positive and your model returns negative, so it's a false negative. So confusion matrix gives a matrix of this, and it will give you an idea of how your model is. For example, in confusion matrix, this is the 0 0, so the true value is 0 and the predicted value is 0, so it is true negative. And this is the true value is 0 and your predicted value is 1, so it is like false positive, and that false positive. And then you have true value is 1 and the predicted value is 0. This is false negative. And this is true value is 1 and the predicted value is 1. This is true positive. So the more the number of incorrect classifications, the less accurate your accuracy is. So in this classification problem, out of like 60 test data, 11 has been classified incorrectly, which is like true negative and false negative and false positive. We don't need to have this data. If you have this as 0, it means it's a perfect model. It will have an accuracy score of 100. But right now we have 11 incorrectly classified, so we have 81% as the accuracy score. So that's about evaluation. So let me show how I've used what all evaluation I've used. I've used classification report over here, and all of these can be imported from, guess what, scikit-learn.metrics, I guess. Scikit-learn.metrics, yeah, import. You can get confusion matrix, classification report, accuracy score, everything you can get from this metrics module. So that is also sorted out for you by scikit-learn guys. And I've used a single method to evaluate the model. I've used a combination of metrics here. So the first one I've used is classification report. Classification report is here, this guy over here, who is giving us the recall, F1 score, support, precision, everything. So you have the F1 score over here of these thing, and you have an average of these as well. And then the next evaluation is confusion matrix, and confusion matrix that you get from scikit-learn will not be visually appealing. For me, if you see, you have colors that distinguish between different cases. So if you want a confusion matrix like this, you just need to Google plot confusion matrix in Google. So it will give you the this code, which is provided by scikit-learn themselves. So you can use that in your application. And you can use it, plot confusion matrix, and you can send the normal confusion matrix to it, so it will transform into a color scheme. And the next one is accuracy score. So you just need to give for all of these cases, what you have to pass in as parameter is nothing but Y test, which has the actual labels, and then prediction, which is nothing but the prediction written by a model right now after after testing it. So once you give this actual and predicted values, it will compare between these two and then give you a score. So accuracy score for this model is 81.6, and for support vector it's 83.3. It did better than random forest. And then decision tree has a very slow score of 76%, and naive bayes has 80%. It's in the intermediate, and logistic regression is the best out of it, which gave 86.6. So if you remember, I told that random forest is a very good classifier. But in this case, you see random forest did not fare well in compared to this logistic regression. So that confirms one fact that no single classifier is the ideal for all kinds of data sets. So for this data set, I think logistic regression has performed well. So it has got 86.66. So that's how I want to conclude that don't come to a conclusion that this classifier is the best and that classifier is the best. So just try it on your data, and then you will come to know which is the best for your data set. So that's about evaluation part. And as I told, these metrics are available under sklearn.metrics package. So now we saw the accuracy value. We saw one of the models have an accuracy of 81.66%. 81.66%, which is not good accuracy. In that case, we might need to improve the accuracy. So we have some techniques for that. So the first one is ensemble learning. Ensemble learning is nothing but you are using multiple models together to improve the accuracy. Instead of using one support vector machine, you are using like 100 instances of support vector machines and then try to improve the accuracy. So in ensemble learning, there are two types. One is bagging and another one is boosting. So let me explain bagging first. Bagging is a short form for bootstrap aggregating. So in bagging, what you will do is you will take the data set and then you will sample it. I mean, you will take 60% of the data set and you will divide it into how many instances. If you have 10 instances of support vector machine, you will divide the data set into 10 samples, and then you provide each sample of it to 10 different models. It might be the same support vector machine, but it is a different model because each will have different data. Some will have intersecting columns records as well, but it is fine. And all of these models will get trained parallelly with the bootstrap samples that it get. Once it gets trained, then you have to pass the testing data to all of these models parallelly, and each of these 10 models, 10 support vector machines that are over here will give you a prediction. So we need to decide which one. We need to decide the final prediction by a maximum vote. That is, for example, out of these 10 estimators or classifiers, 8 of them would have given the label 0, and 2 of them would have given the value 2. In that case, 8 is high, right? So the final prediction will be given as 8. That is maximum vote. So 8 of the models over here have given supported for 0, and 2 guys have given 1. So definitely they will go for the majority guys only. So that's what bagging is. So it will supplement the strengths and weakness. So if one model is weak, the other model will perform well, and based on maximum vote, you will get the correct value. So even this is sorted out for you. So scikit-learn has a solution for everything. So it has bagging classifier for that. So first you need to import. I will show the import part because I'll be going to the end of this thing. So you can import it from scikit-learn ensemble, because it is also when you are using multiple classifiers at once, it is called ensemble. So you are getting it from ensemble bagging classifier. Once you get the bagging classifier, so this is ensemble learning. I have created an instance of all the classifiers that I have used before, and I'm going to use I have imported bagging classifier, which I showed you now. So now while creating a bagging classifier, you need to pass some parameters, which is nothing but the classifier that you are going to use for bagging. First one is random. I've tried with random forest. I've given random forest, and max samples is like 60% of the data set will be sampled for each of these models. And then max features is like whether you have to use all the features from the data set So if I give the value of 1.0, it means use all the features. If I give like 1.5, then use half of the features. And n estimators is the number of estimators. I wanted to give, like, I want to use 100 random forests together. So this is not a fixed value. You can experiment with this and you can see the accuracy score at the end. For me, I tried from 20, 30, and then I tried 100. I also went to 200. But as I increased the number of estimators, the accuracy started decreasing. So the 100 estimators gave me the best value. So after that, we have to fix all these parameters while creating an instance itself. And then once you create an instance, you can just like training a model, you can again train it. You can train the training data with it, and then instead of predict, I can directly use score in terms of Bayesian classifier, because it will directly compare the actual and the predicted value, and it will give you the accuracy score. So the score is 0.85 when I combined 100 random forests together. Next, I tried with support vector machine. So 80, I'm not satisfied with 85. I don't want a model with 85 accuracy to mess with with a heart disease prediction. So I went for the next one, which is nothing but support vector machine. Support vector machine, even I experimented, but as you go more, it starts overfitting the data and the accuracy will be less. So support vector machine gave a good result, and it gave the highest result of 0.9. And you can also use heterogeneous models. That is, you can use different estimators rather than using the same support vector machine. You can use one support vector machine, one naive Bayes, one random forest, one logistic regression. Voting hard is voting. If you give voting hard, it is based on the number of votes, and if you are giving voting soft, it is based on the probability distribution. So always go with voting hard, because it gives good result. So I'm combining all these estimators together, and then I'm training it. So it is so I'm training it with this classifier. So we have created it is called voting classifier. I forgot to mention that. This is Bayesian classifier. Since we have different estimators, so we have to use the voting classifier. We have to choose the result out, the majority of what majority has given, and then we have to fit the training data on it. And then once you have fit the data, then you can check the score of it. But unfortunately, it didn't do better than this support vector machine. But this is also a path of this is also a way you can improve the accuracy. That's what I wanted to say here. So boosting is another method. In boosting, what you will do, it's not parallel, it is sequential. That is, first you will train one model, and then it will give you its predictions out, and then you will find its incorrect instances, and you will add more weight to those incorrect instances, and then you give the data set to the next. You will give the data set to the next base learner. So the learners here are called base learners. First you will give a data set, and then it will give prediction, and then for the incorrect instances you will give more weight, and then the next learner will rectify that, and it sequentially keeps increasing the accuracy. So finally the results are all combined, and then you will get the best accuracy of it. Boosting is also a very good technique that you can use in a classification problem. If the value, the output, the accuracy, you're not satisfied with the accuracy. So scikit-learn has a solution for this as well. So it is called scikit-learn.ensemble.gradient boosting classifier. There are other boosting methods as well, which are called AdaBoost and XGBoost. But first, if you get used to this, then you can explore those things as well. I don't want to confuse with some big names there. And then the next one is feature classification. Feature classification is a different improvement technique. So if you see a data set, there will be like 100 columns, but only 10 or 20 of them will be contributing to the final label. Others are just lying there for the sake of lying. So in that case, you can eliminate some of the features. You don't need to have all the features, because when you give a lot of data, machine will take time to learn, and it might not learn well as well. In that case, if you can eliminate some of the features that are not contributing to the final result. If something is not contributing, why should we have that? So that's the ideology behind this. So first, what you have to do is remove the highly correlated features. What does it mean? It's like there will be some features which more or less gives the same information. So in that case, you can manually remove those. You can see the data set and you can see what value this field is giving, and you can remove it directly. If there are two fields that are almost giving implying the same thing, then you can remove one of it. And so the idea of recursive feature elimination is that you start with all set of features and then you create a model, you see the accuracy like we did right now, and then you're not satisfied with it, and then you start eliminating. You try different combination of features, like you eliminate. We had 14 features right now in our data set, so we can so the accuracy was just 81.66. So we can remove one of the feature which is not used, which we think is not useful, and then we'll try with that combination. Same way you can try removing all the other features, which you think are not useful, and that thing has been handled by and the final one is the combination of feature which gives you the best accuracy will be chosen. So it's nothing but just trial and error. You just try to remove one feature. You try out with 13 features. You try out with 12 features. You try out with 11 features, and then you finally fix that having these 10 features gives you the best accuracy. So that's what recursive feature elimination is at. From the name itself, you can understand it's recursive. So 14, 13, 12. So you stop at the time when you feel that this is the best accuracy, and you don't need to stop in between. You can try out all the feature combination and then finally come to a conclusion. That has been handled by, you don't need to do it manually. You might be intimidated by telling how many combination you have to try. You just don't need to worry about that as well, because scikit-learn has a solution for this, which is called feature selection. RFE stands for recursive feature elimination with cross validation. So when you have to just give the estimator and this, and then it will give you the final result, like number of features you have to retain to get the best accuracy. So it is like automatic. You can use this and you can import it and use this when you're using it. So this is, you can try out feature selection as well when you have a lot of features and some are not contributing to the final result, which will definitely improve your accuracy. I've seen results in this. So that brings us to the end of classification problem. Successfully we have completed these. I have just given some stats here. So we have come to the conclusion of this classification problem. So we started with I'm just going to give a short summary of what all we went through. So I just went through a whole classification problem. So whenever, if you're going to do a classification problem from today, you just need to have all these elements in this. First, you need to start loading the data set. Then you need to pre-process it. You need to check for any inconsistency and pre-process it. Then you need to visualize it to get an idea of the data, like how many negative cases are there, positive cases are there based on your data set. And then you need to split it. If you don't have a testing data, you need to split it based on what ratio you want. And then these are evaluation tools I have defined. Then you can start with the training and testing. And you can define the evaluation tools like confusion matrix, classification report, and everything is available in scikit-learn. You don't need to worry. And training and testing is over. Once you find the accuracy, you're not satisfied with the accuracy, you can just go to the improvement techniques. You can use ensemble learning like bagging, boosting, which are available in scikit-learn. You can do feature selection, whatever. You can just try to experiment it. So data science is more about experimentation. There is no fixed go-to path. You just need to experiment with the data and see what is best for you. So we have come to the end of classification problem. So let us concentrate on a specific application field, which is healthcare field, because I also encourage students or data science aspirants to focus on this domain, because when you do some application in healthcare, it's going to benefit our society and people around us. So there have been many discoveries. Researchers have found many use of machine learning in almost for all the diseases. Some of the notable ones are skin lesion classification. You can say whether it is melanoma or not just by looking at the skin images. And heart disease prediction, we just saw a live example of heart disease prediction. And then epileptic seizure recognition by seizure episodes. You can recognize whether the person is going to get seizure episodes or not. You can also get stroke detection. Stroke is also a major health health disorder. So in that case, we can direct stroke detection as well. And then blind vision is another example that will help you to that will give vision to blind. This comes under deep learning. This is not just the normal machine learning, that normal non-deep learning models that we saw. We need some deep learning knowledge to implement some of this. And even this needs deep learning because it deals all whichever we deal with images, we need to start doing deep learning. So I'll be talking about it right in a few slides. And then sensor data. So smartphones now are equipped with lots of sensors. We don't know the names of few of sensors that we have in our phone as well, but it is present. You have to believe that. So you have so based on that sensor, we can utilize that sensor. And if you know a bit of Android programming, you can use that, and you can imbibe machine learning, and you can do useful applications with it. The first one is like you can use activity recognition using accelerometer data. Accelerometer is nothing but it gives the X, Y, Z coordinates of your phone. For example, if you're sitting, then the phone will you will have it in your pocket, and it will have a specific X, Y, Z coordinates. And if you're standing, it will have different specific X, Y, Z coordinates. So it depends on what position you are there. So you can use that data you can use the position of your phone to find the activity that you are doing right now. That is activity recognition. So image classification using camera. Camera is also a type of sensor. So you can classify images using a camera. And step counter. So pedometer apps has been it's people are using like crazy right now because everyone are fitness minded right now. They wanted to see how many steps they have walked. So you can create your own step counter using accelerometer data. So you have an Android phone, and if you know Android programming, Android is a very open operating system, so you can access all the hardware present in it. So you can use the accelerometer sensor that is available, and you can find the step counter as well. And then the next one is blind vision using object direction. Blind vision. So object direction is one of the problems in deep learning. So it deals with images. So you give an image and it finds different objects in the image. So you need to know convolutional neural networks. It is in the area of deep learning. So blind vision, you can give some caution alerts to blind people using your camera and using object direction algorithm. So now we are transitioning into deep learning. So I just wanted to give you an idea what deep learning can do, because you guys will start with normal classification problems, and then as you get good with it, you will try to go with something ambitious like deep learning. So in that case, you can leave this scikit-learn and you can go with TensorFlow, because TensorFlow is an open source deep learning framework by Google, put together by Google. It's a very good framework that gives pre-trained models like image classification, object direction. So you can use those pre-trained models for your application, or you can retrain it for using your image data. So from here on, we are going to be talking images, not textual or numerical data. So the models that are available in Tensor, the pre-trained models, that is, they have already been trained with lots of images, like 10,000 images, which cannot be done by normal individuals. So the first one is image classification. So I need to talk about TensorFlow Lite. Everyone would have heard of TensorFlow, but you would ask, what is this Lite? So right now, what I'm going to explain next is blind vision. I've done a project called blind vision, which is an alert given to blind people while they are walking around their house. So for that, it's deep learning stuff. So I've used TensorFlow, but also I've used on mobile phones. I'm using the camera of the mobile phone to use that. So in that case, we cannot use the normal TensorFlow because the models are very heavy. You can't use that directly on a mobile phone because it is energy consuming, and it will take lots of energy, and the battery will be drained quicker. Like in half an hour, your battery will be drained if you use these applications. So in that case, TensorFlow gives a solution like TensorFlow Lite. TensorFlow Lite is specifically made for mobile devices because it's lightweight models that you can use on it. It is quantized, and it will take very less energy compared to the normal TensorFlow models. And they provide image classification, so you can directly use it. They have given you the code in their site, and then they have given object direction as well, and they have given pose estimation. Segmentation is like segmenting different parts in your image. That is also given by TensorFlow Lite. All the models that are available in TensorFlow Lite can be accessed using using this URL. If you go to this URL, you'll get an idea of what all models they provide directly, and you can use it or you can retrain it. So let's go to our application. That is another deep learning application that I did for my project, for my course. So it is called Vision for Blind. This is nothing but an Android application that uses camera to detect and uses object detection, TensorFlow object detection model to detect object in front of a blind person, and then it gives an alert using text to speech to the user, so that he does not run into something or he does not get into any chaos. And so the blind people find it very difficult navigating around the house, even in indoors as well. They need some attender to help them with help them moving around. So we thought this is a good application. I'm always a good advocate of using machine learning for health. So I chose this topic for project. So I'll be explaining more about this project now. So the model that I used is, as I told, TensorFlow Lite gives you object detection model directly. So it is actually it is using a convolutional neural network called MobileNet. I haven't explained you convolutional neural network, but it will take a lot more time if I have to explain that. But just you'll definitely, I'm giving that in your path. You'll definitely be learning later. But just now, for now, just remember that this is done using convolutional neural network. So MobileNet is a convolutional neural network that has been trained on 10,000 images from Coco dataset. So it is capable of detecting any images like apple, banana, and the image, it takes an images of 300 into 300 pixels, and the output that you get is like the class. The class means nothing but label. Just like numerical data, here also you have a label called banana, apple. So that's class. And confidence score is this 80%. So it is 80%. The model is 80% confident that this is a banana. So that's what it means. And location is the location of this bounding box. All the object detection algorithms will give you a bounding box output, which means it shows this object you see a rectangle here and it shows this is a banana. So this is called bounding box. And TensorFlow Lite has been pre-trained to recognize 80 classes of objects. So they have only trained this 80 classes of images, and each of them, many number of images have been trained. And okay, I wanted to show you the label map, but I will show you at a later time, not right now. So this is what I'm going to use this object detection model from TensorFlow Lite, because since I'm using on a mobile device, I'm using this Lite model. Transfer learning is another important concept that I want to explain you guys. Transfer learning is another important concept that I want to explain. When you're doing a project with images, just like working with deep learning, and you are working with image data, images generally require lots of images, not like hundreds. It might require 500 and 600 like that. In that case, you will not have 600 images or very good images that you want. So in that case, it's not you don't have the resources and time. And even training takes a lot of computational power, which will not be available in normal laptops or computers. You need TPUs for that. So it's very difficult to train with lots of images. So in that case, it's a good idea to use transfer learning concept, which is nothing but using already trained model and then training it for new images of your choice for your application. In that case, you can train with less images. You can train with around 50 images as well, and it will give a good result because it has already learned 10,000 images and it knows how to learn from an image. So that's the concept behind transfer learning. So since I told you in the last slide that I will be using object detection model, I'm going to use object detection model by TensorFlow Lite, and I'm going to convert and I'm going to train it on my images that I want. So that the process of transfer learning involves these steps. Let me go through the steps. First, I definitely need to collect images, just like collecting data set. Getting a data set, I need to collect images. So since I'm doing a vision for blind, that is for indoor setup, I need to show common obstacles like doors, walls, bedrooms. So I collected like 32 images, just 32 images of bedroom and doors from the internet, and then I put together in a separate folder called data. And then I need just like classification problem where you have a label for each record. Images should also have an annotation, or annotation is also called as label. For that, I've used a software called Label IMG or Label Image. So this is a door image that I got from the internet, but I need to show the model where the actual door is. For that, you need to create a bounded rectangle around the object of interest, around your object of interest, so that you don't need to worry. If you download Label IMG, which is a open source, or it is a free software that you can download from internet. And once you download that, you can load your images in that software, and you can just draw bounding boxes around your objects of interest. Here it is door, so I've drawn the bounding box around the door, and then I'll give the label just like in classification problem, and then I will name it as door. So and then once you do that, you can save it in XML format from Label IMG, and then you need to convert it into CSV format, because everything works as CSV in machine learning world. And then from CSV, you have to convert to TF record, which is nothing but TensorFlow record. You don't need to worry about all these terms, jargons here, because these piece of code is already available in the site. You just need to use that software in your application. You need to convert between these formats. And then training. So when you're training, you need to provide a new label map. So that's where I'm going to go to show you what label map is in terms of. So let me go to the TensorFlow Lite object direction model page. So that's where I downloaded the model and label map initially. So this is a TensorFlow Lite object direction model. I have used Tensor object direction model. You can use image classification. It's totally based on your application interest. So when you go here, there is a button called Start, Download Starter Model and Labels. If you click on it, you see a Cocoa SSD MobileNet has been downloaded. So this is .tf lite file is the actual model, and which has been pre-trained already. And the label map is your map of labels. So this is the final label field that you saw in text data. Just like that, for images, you need to create a separate text file and then give all the labels that are available, label of images that are available. So these many kinds, as I told you, there are 80 classes of images that they have trained on it. So these are some of the labels here, like person, bicycle, car, motorcycle, airplane, like that. So whatever you are going to, when you are going to train on a new data, you just need to create a new label map and then fill it with the type of, with the label here. And then you need to change the parameters in config file. So you don't need to worry about it. Config file, when you download that model, you will get that config file along with it. And TensorFlow has their more models ready. So you can download and you can change the label map. You can change your label map in that config file. By default, they would have given their label map, which is available right now. You have to change the location of your label map there. And then you have to provide the TF record. When we finally convert it to TF record, the images into annotated images into TF record. So that is actually your training data. So you need to provide the location of that folder as well in that config file. Everything you are doing in the config only of the model. And then you have to give the checkpoint of a train model. Checkpoint is nothing but the model that we downloaded right now. I saw they gave you a TF Lite file, right? That's the train model of checkpoint. So that is nothing but SST MobileNet in our case. There are different nets like AlexNet or BGGNet. So right now we are using MobileNet. You can learn about it in the internet when you have time. And then I've used, since I told like images are not friendly to train in your native machine, so you need some support of a cloud interface like Google Compute Engine. Google Compute Engine, you can go to Google Cloud Services. You can just get a free subscription. Hello? Yeah, ma'am. Complete panta, ma'am. 1 minute, ma'am. 5 minutes. Yeah, 5 minutes, ma'am. Yeah, sure, ma'am. Sure. Thank you. Thank you. Okay, ma'am. Sure, ma'am. Thank you. Okay, sure, ma'am. So for computing, you can use Google Compute Engine, and you can use Google Storage Bucket for storing the images. And Google Colab is also a good tool. These are all free sources. Google Colab is free, but you have a free tier account when you create a new account. So for storing images and for computing, you can use this. And finally, once you have completed the training, you'll get a frozen graph. And then for frozen graph, once you get the frozen graph, you can convert into TF-Lite format, which will be used on Android programming or Android device. All the process will be explained in this tutorial. So if you are interested to use some deep learning like image classification and object training, and you're going to train it for your own model, you can go to this article, and you'll get a good idea of how to start with and what to do to train with your images. Android text to speech, yeah, so right now we have an application that will open up, that will show, that will activate the camera, that will detect the objects in front of you, and there is a model behind it that will predict what objects are there on the screen. And then you need to give the output to a blind person. Definitely blind person can see the text, what objects are there in front of them. So in that case, you need to give a voice output because they can hear the voice. So for that, Android has a fixed solution, which is text to speech module. So I created, when I used Android programming, I created a separate class for speech, and you can use text to speech module for that. And I've given the output of the model every 9 seconds, so that the user will get notified that something is in front of you. Be careful while you move forward. So that's how this project was implemented. Let me show you the output. I've just shown you one test case where I'm moving towards a refrigerator, and it is cautioning me there's a refrigerator in front. Be careful.
There is a refrigerator in your path. Please be cautious as you move forward.
So in case if the sound is less, if you guys feel sound is less, you can see again. It's just I couldn't. Yes, you can see that.
There is a refrigerator in your path. Please be cautious as you move forward.
So that is one simple output, and we tried with many other outputs which was successful. So similar way, you can reuse the image classification observation model to create an application of your choice. So that's the deep learning part. So the learning path is, first don't start with deep learning or something like convolutional neural network. You'll be intimidated because there are a lot of concepts behind convolutional neural networks and how it is working. So I explained you the whole problem of classification. So from today, you are good to start with classification and regression. Once you're comfortable with classification, regression, and normal thing, which you can use with scikit-learn, and even clustering you can try. And then you can go with the deep learning arena where you have Keras. Keras is a package which allows you to create a neural network in just 10 minutes. So that easy it is. Keras is also has a very good documentation, so it is pretty easy to start getting started with neural networks. Convolutional neural networks is somewhere where you have to spend some time learning about it before you start using TensorFlow, because TensorFlow is entirely based on convolutional neural networks and image classification and object detection, as we saw right now. And then start reading research papers. This is some very good recommendation that I want to give, and I want to stress about it. So machine learning is an evolving field. It is not yet fully developed. So in that case, a lot of people are striving to give new solutions. So please try to read as much research papers as you can. If you're trying to implement a specific application, just go to that field and see what all what all has been already done, and then try to think. When you have gone through all this, you already know the possibilities of machine learning, what you can do with that. So after that, if you start reading research paper, you will get an idea of like what has already been done and what you can do in future. So this is the right time to start research papers, because a lot of these research papers will use these terms. You need to know these terms before you can start reading research papers. And then once you read the research papers, you can start your new problems, start trying out new problems. So that's the part I'm suggesting. So I hope this path will be useful to you, and I also hope that you guys start doing from today. So questions. I think I have a few questions. I will start answering some of the questions here. I can't answer every question, but definitely I will answer some of the question. So first question is by Mohammad Riaz, asking, sir, is Java used in machine learning? No, Java is not used in machine learning. If you're serious about machine learning, just get used to it via Python. So Python is everything when it comes to why should we use in Python. I think I explained this question first because it has a lot of packages. It saves you a lot of time. when you compare it Java and Python itself, you know that you can write the same code with less lines of code in Python. So the same reason goes with machine learning, and there are a lot of packages for machine learning in Python than other languages. Karupanan, P. Karupanan asks which one is best one used in ML, whether Python or MATLAB. Yeah, both are good. I can't comment which one is best, but Python is recommended because of its pervasive nature. It is available everywhere and it is very useful. Most of the hardcore data scientists used by Python, so I suggest go with Python. What is the purpose of Anaconda tool while learning ML? Oh, yeah, I forgot to mention about Anaconda. Anaconda is an environment where you have all the data science packages. So when you're working with data science, the project, you might need different packages while you're working. So if you download one Anaconda environment, it will have all the packages installed. So you can directly use that packages right away. How to avoid overfitting your model and find the right fit? Where can we get a data set by Aravind PL to learn pre-processing and converting a semi-structured data to structure? So overfitting is definitely can be done by using bagging or boosting. And okay, so you can use the techniques like bagging and boosting to remove overfitting. And so how much time will it take to do a career in machine learning by this early 2000? So that's a good question, but there is no definite answer for this. It is for machine learning, I would suggest rather than practical perspective, get used to if you are very serious about machine learning, get used to this mathematical side of things as well. There is a course in internet for called MIT courseware for mathematics. Please start from mathematics and then get to the practical perspective. You can definitely make a career in 1 year time. So what is the difference between machine learning and deep learning, sir? Pranav Ramamurthy. So that's a good question. So machine learning, you saw the first models like classification. Deep learning is just that it has more layers, just like neural network or convolutional neural networks, which is giving a result out of a lot of processing after going through a lot of layers. That is deep learning. From the name itself, you understand it's deep. So that's deep learning. So I think there's a lot of questions, but I tried to answer as much questions, but due to time constraint, I could not answer all the questions. Thank you. First of all, I'd like to thank IT department of Panimalar Engineering College and bottom of my heart for giving me this opportunity. I've always been looking for an opportunity like this to teach people, and IT department, I think they gave me such a great opportunity to extend to such great number of people, and I will always remember this help that they have done to me, and I'm always ready to help more as well. So if you guys have any questions or any queries, you have my LinkedIn profile. You can connect with me and you can talk to me anytime. I'm always there to help you, and we can even work on projects together. I'm interested in collaboration as well. So if you have any such ideas, please don't hesitate to come to connect with me on LinkedIn and talk to me. We can work together. And thank you so much. Thank you all for attending and patiently asking all the questions. And I hope this webinar was useful, and you found something useful out of this, and you will start learning machine learning from today. Thank you so much, guys. Thank you for your time. See you later. See you in another webinar.
Thanks for your innovation talk, Mr. Arvind Balaji. On this account, I would like to extend my thanks to the management, the principal, the head of the department, and all the participants who have attended this session. Once again, thank you all.